Yeah, so this talk is a little bit of a kind of like position talk and a bit of a rah-rah talk. So I'm kind of hoping some of you might get to the end of this and quit your jobs and start working on robotics selfishly because I want cool robots. And in this talk, which is going to try and convince you that multimodality and multimodal sequence models with language capabilities have unlocked robots. I'm not talking about just any robots, because we actually already have some robots going around right now. I have a Roomba. I've seen, we've all seen the Boston Dynamics Spot robot in the bottom right of the slide. And self-driving cars are sort of like the world's largest and best known robotics project. But these robots all have one thing in common, which I know personally from working with my Roomba, which is that their user interface makes you cry, which is surprisingly enough not in that stock photograph. So I had to add it in a little bit later. You've got an iPad, you've got some interface where you need to interact with this thing, and it's a moving physical object. And most of the moving physical objects that we like interact with flexibly in our environment are people or well-trained animals, which we can communicate with. And so the kind of robots that I'm excited about and that I'll be talking about here is robots with a language user interface, where I can be sitting down at my Google cafeteria lunch, eating my free mashed avocado and say, you know what? Hey, robot, I just worked out. Bring me a drink and a snack. Not have to enter like into an API precisely exactly what I want, not have to, God forbid, get it myself. And then this is done by a robot for me. So that's the vision here. And my argument is that some of the fundamental blockers in place in front of this kind of technology have been opened. There are still some, and it's an exciting time to work on them. So the TLDR of that argument is tool use is this new first-class feature of language models that unlocks a ton of capabilities. And a robotic body is just another tool. But unfortunately, language models that are just language models can really only see text. And this is untenable because we don't have SDK access to the physical world that exposes the world as a state that's a bunch of strings. And so what robot controller language models need instead is multimodality to give them context for their actions, not just so that they can know what actions to take and not just hallucinate actions they can't do, even though it would really make their user happy if they could. But we don't have any robots yet because atoms are hard, and I'll talk a little bit about what the problems that people report in working on this. But that just means there's a bunch of really exciting hard problems to solve. Okay, so now let's go through that argument in detail. So tool use is this new first-class feature of language models. So back in 2019, there was a paper giving BERT a calculator that talked about how you could like intervene in the middle of a language model and take its outputs and like to put them into a tool. And in this case, a calculator to make up for the fact that BERT can't do math. And that makes it hard to do certain kinds of question answering. And now within the last couple of weeks, the dates have blurred together. I guess June 13th, it's right there on the slide. OpenAI has released function calling as a feature of its latest iterations of GPT-4 and GPT 3.5 Turbo. This causes the model to output, instead of text or a particular type of text, you might think of it, a JSON object that are arguments to call some function. And people really run away with what the definition of a function can be. It doesn't have to be implemented. It can be in any programming language. It's a very general interface. And this is something like loosely, this pattern, goes back to giving BERT a calculator. You may have heard of it from the React pattern or some of the agent work that people have been doing. It's this pattern of function calling and tool use is in the LangChain library and has been for a long time. So part of what's happening now is that the quality of tool use has gone up. The reliability of tool use has gone up with the fact that it's baked into OpenAI's latest models, and surely others are soon to follow. So the kinds of tools that people have been working with are, Google search, calculator, Wikipedia. If you're a real YOLO energy, you might give it a shell to run on your computer, or even access to a Stripe account. Maybe you're running Hustle GPT to try and start a small business. Those might not be good ideas, but they are possible. These are many ways of interacting with the world, is how the LangChain docs put it. But these are all just like text interfaces to APIs of some kind. And that's, the World Wide Web is not, in fact, the world, no matter what it feels like when you're on Twitter. And the real world is full of bodies, but bodies can themselves be tools. Robot bodies, primarily, until Neuralink does another 20 years of research. So the kinds of, robotics in general, the innovations start in a simulator. And so you work on ideas in a simulator and get them out into the real world afterwards. So a lot of the research that has been gone on so far on using language models to control something that looks like a body and environment has happened in Minecraft. Of all places. It's actually kind of an interesting choice. It's open-ended. There's lots of resources to gather, potentially hazards in the environment. There's a complicated chain of steps required to mine a diamond so that you can make a diamond sword so that you can grief your friend. And so people have been working on this as a task in reinforcement learning. And it turns out if you prompt a language model correctly and add some control flow around it, you can get it to output goals that a controller can use to, like a controller that can do simple tasks in Minecraft can use to do a much more complicated task by planning, seeing whether the plan succeeded, and adjusting behavior. So this gives you a high level interface like mine a diamond, and then this like high cognition in the intervening actions of the robot. You go even further. LMs are really actually generic programmatic controllers that can learn. So they don't need to come in knowing exactly what it is that they are able to do. If you give them the ability to write code to control a body, so they write code to control this Minecraft agent, then they can get really, really good. So not just mining a diamond, but mining enough diamonds to make a diamond sword, and all kinds of other difficult Minecraft tasks, traveling, hunting, traveling the world, fighting Enderman, etc. And so there's been a ton of advancement in using language models as these kind of controllers. And one of the blockers that's preventing people from taking this this Minecraft controlling system Voyager and just directly putting it into a Boston Dynamics robot and unleashing it on America's national enemies, is that language models can only actually see things that are text. So there's something behind the screen with something like Voyager. The sensors, the natural sensors that you might imagine that Minecraft body has, see something like the top left. They see this, like they see pixels that are they relate to the eventual state of the world, but you don't see the latent hidden variables that are the state of the world. But instead of seeing that, the language model sees this extracted version of that that's based off of the game engine. And so like it sees something more like literally it sees the thing at the bottom, which is like a bunch of text that describes the state of the world. And we don't happen to have access to the world's SDK, which would print this information out for us. And so this won't work for robots directly. And to be clear, like with Minecraft, you can do it like directly from the pixels. You could throw out the language model and say, I'm going to learn, I'm going to do reinforcement learning straight from the pixels. But it's like very hard. It's very slow, takes a ton of very specialized data. And the result that you get is not as capable and not as robust. So we want to keep the language models, but lose the language restriction. And so multimodality gives robot controller language models the requisite context to be able to like appropriately take actions without needing this like cheat of direct access to the state of the world. And the like results that you can get when you do this right are like positively magical. So this slide is really something to just like sit and kind of soak in what is possible when you have a model that is trained on text and on images. So this is Google's Palm E, which was designed not just for multimodality, but for embodied multimodality. And so some examples, you have things that look like what a self-driving car might need to do. Zero-shot multimodal chain of thought. Given this picture, can I go down this street on a bicycle? Yes or no? Let's think step by step. And for the purposes of this talk, I want to pull out this image in particular, robot initiative, as a task. Given this state of the world, represented as pixels, if a robot wanted to be helpful here, what steps should it take? Clean the table, pick up trash, pick up chairs, wipe chairs, put chairs down. So this is the kind of thing that we really want out of our generally capable language interface robots, this sort of like very flexible and loosely defined behavior. You can get a ton of utility out of something like this. And there's already early indications that it's possible with the multimodal technology that we have right now. And so Palm-E has as its interface sort of like tensors in, language out for the core component of the model. So it's a multimodal language model that is like any modality can come in principle, and text comes out, and then that text can be used to, say, control a robot. And so the way that they solve that is they sort of like train these very specific like embedders that map into the embedding space of this model. So you take an image and you turn it into a sequence of embedding vectors, or you take the outputs of maybe you have some like LiDAR thing that gives you the information about like point clouds, or maybe you have some 3D scene representation. You convert that into an embedding, and that embedding goes in to the language model. So you have this kind of like universal embedding space of this highly multimodal model that uses sort of language as its kind of core control, one of its most important context setting modalities, and as its primary output. The alternative interface that people have been doing is language in, language out, which is to say that the state of the world is turned into a string somehow. It's stringified. If you thought that your serialization problems were hard for your website, I challenge you to try it for a robot in the world. But people have been doing it. And so you take maybe it's a neural network that has some kind of output, and you turn that output into a string rather than taking it as a tensor. And so you have some kind of adapter from your sensor to text. And that the benefit there is that there are lots of things that can transform things into text, and you kind of decouple the model, the language model, from its inputs. The disadvantage is maybe the quality of results that you can get aren't maybe as high as what you can get with doing the whole thing kind of end to end. But one example of how this has been used is in SayCan, which uses text as a description of the state of the world, and which is used as input to value functions to help the language model decide what it can do and what is valuable at a given time. So that's what was supporting that example of the I just worked out, bring me a drink and a snack, was based off of SayCan. I noticed while putting the slide together that the power cord for the robot is unplugged in this photograph. So I guess it is in fact staged, but there are videos that show it actually doing stuff. Okay, so that's sort of, I've talked a little bit, kind of like a bit about the interface there. Also, the like language model is providing kind of like a cognitive component, a cognitive module for the robot. So Inner Monologue is one of the papers that dives the most into this. And it talks about how it shows like some examples of phenomena that come from a robot whose controller involves a language model. And the example in this one is a human says, throw away the snack on the closed counter. The robot goes to the counter and gets ready for its next step. When the human says, actually, I changed my mind, I want you to throw something away on the table, the robot flexibly switches tasks. So this kind of flexibility is really critical for a useful general purpose robot. It can't be a factory robot that's just repeating the same thing over and over again. So the ability to flexibly replan in response to general language inputs. And this is with a very primitive cognitive architecture, none of the fancy bells and whistles that go into the two Minecraft agents that I showed. So you can imagine things would get a lot spicier once you added that. There's a whole bunch more interactive guidance of a robot. So it's moving around and you're like, no, a little bit more to the left. You got it. So, for self-driving cars, that might be helpful for tricky parking jobs. That's sort of a little bit, language interface from a human. Vima is a recent piece of work, I think mostly from folks at NVIDIA, that does multimodal prompting. So there, again, you're taking your sensor information and you're putting it into the prompt. So that's kind of more of the tensor interface. And this trains from scratch. It's a very small model, but fairly capable in a simulated tabletop environment. So I expect to see some really cool results from that team as they move out of sim. in the category of things you can do with this, personalized robot assistants for cleaning your room. You can tell it sort of like, I like my shirts in the closet and I like my socks in the hamper, and it generates a plan on the basis of that and like uses that instead of needing like you to exhaustively detail all possible things that might be in your room and where they should go. So using a language model as like a component of a robot interface. And then there's also probe prompt, which does this kind of pseudocode programming of a language model as so using actually code rather than truly natural language as the interface into the robot. So maybe a human is on the outside using completely natural language that gets converted into pseudocode or code, and that is used to then drive the robot. So that has some in real life results, and again, sort of more in this like robot arm pick and place kind of situation. And in terms, so that's all that stuff comes from research. There's also some folks at Orangewood Labs who are working on actually productizing this. So taking a robot arm and giving it a GPT style, ChatGPT style interface so that you can ask it to do stuff. So they're not commercially available yet, but when I talked to them a couple of months ago, like they were excited about getting it out, hashtag soon. So with all this work, you might be wondering why, where's my robot? So some of the causes are short term and are not as like maybe interesting. Hardware development cycles are long, so just like cool it. The top capability multimodal models are not generally available, and when they do come around, they're only going to be available over API. So that's kind of a blocker for a lot of robotics things where you want to do things maybe on device in a tight, hot loop. So Palm E is from Google. That was most of, and Palm in general is from Google. That was a lot of the results. GPT-4 from OpenAI, the multimodality is not publicly available. Flamingo from DeepMind is also not publicly available and also is a highly capable multimodal model. But there's some promising early results in open models, including Lava, Llama Adapter V2, and Open Flamingo and Otter. Still maybe like a lot of work to go there for that like really flexible natural language interface and being able to talk back to humans and get feedback, but on the way. We have open source text and image models that are really good. They're just really good at making pictures, not driving robots. Like Stable Diffusion is a multimodal model, but the open community is not pushing on robotics. They're pushing on image generation. So I expect once people kind of like cotton on to this, that some of those ideas, some of those tools will just port over. There's also a gnarly silicon shortage, which is part of like underlying all of these things, slowing development cycles, making it harder to make a generally available multimodal model, slowing down the community. But fundamentally, the real blocker, atoms are really hard. There are other hard problems besides cognition that robotics is still blocking on. You want to do on-device inference in a lot of cases. You have tight restrictions on the things you need, compute and VRAM to run big models. You also have power and heat as restrictions. Even if you just staple an A100 onto your robot, you are going to need to bring in a lot of power and you're going to generate a lot of heat. So if the idea of getting an 8 billion parameter model somehow to run on 2 gigabytes of VRAM and 5 watts of power is exciting to you, check out the Jetson Nano and try and build a robot that uses it. Bodies in general are also hard, the ones that are not in Minecraft but are in the real world. They have sensor drift, they have component drift, these things fail. Our bodies heal themselves for a few decades, and so aren't as subject to this problem. Robot bodies are. Also, this has been the most bedeviling thing for the self-driving car world. Cars are incredibly good robot bodies with great sensors and great components and a worldwide system of delivering them power and repairing them, but the mistakes are very high stakes. And so you have to get very good. And then lastly, a lot of this, you need to turn natural language instructions or tensors into actions in the world. And so in the end, you might have to actually do, God forbid, some reinforcement learning or low-level robot control coding. And so those things are challenging and are the sort of components that once somebody builds one that's fairly general, like the Minecraft MineFlayer JavaScript library used by Voyager, that can be used by many people probably with a language model adapter on the top. But those things need to be built. And then lastly, you probably want this thing to operate in real time. And many of today's demos, like the ones that I showed you, are operating slower than real time, even when you 5x speed them. And so there's some fun low-level programming to do to speed those things up. And you might need to be thinking about video multimodality and not just image multimodality. I sure hope somebody is thinking about video understanding and video embeddings and video multimodality. So I consider this like a huge set of challenges of exciting work to be done to sort of like bridge this gap now that the cognitive limitations on generally useful robots with language interfaces have been removed by the development of language models and by emerging trends in multimodality. All right, so that's my view on the state of research. You can, I guess, quick pitch for what I do. I teach people how to build products with neural networks, so I taught the large language models bootcamp. It's available online. You can find it at that QR code or at that link at the bottom if you're more of a text than a vision modality person. Yeah, we go through a lot of stuff about what it takes to build a large language model powered app. Great. And I will, I think, answer questions after the next talk, but you can also just toss them in the chat and I can answer them async.
Fantastic. Thanks for going over all that research and outlining the, I guess, the reasons, right, that you mentioned, both short-term reasons, but also like some of the long-term challenges of working with sensors. And if you have any attendees, if you have any question, feel free to post in the chat, and Charles can answer them in real time, and you can share a slide there as well. I guess just one quick question from my end before we move to the next talk from Cosmos. Like you probably quite familiar with like the traditional paradigm of working with robotics, which is like using a lot of the deep reinforcement learning, right? So maybe just a quick take on this one. Like, is there a way to like sort of combine that paradigm with recent advancement in multimodal LLMs? And if so, like what is the best way to move forward, judging from your survey of literature as well as talking with real world practitioners?
Yeah, I think there's two places where reinforcement learning is still a critical component of the stack. One right now, and one probably in the near future. So at the very bottom of the stack, like your effector policies are often going to be reinforcement learned, like that low-level policy about like pick up an object. That's just like with an open vocabulary, with an open domain in a general human domicile, you aren't going to be able to like hand code that the way that you can sometimes get away with some other kinds of policies. And I think they're likely to be deep RLE if they are very open domain, rather than being some like classic control policy, like a linear quadratic regulator that you would use for like, you know, locomotion, some of those other policies. And so RL and even deep RL are still going to be critical at that like bottom layer. Then I think right now language models do not really use that much RL. Like there's RLHF and RLAIF for alignment. Those are very simple forms of RL. It's like you get a single reward scalar at the end of an episode. It's not this sort of like online, more agentic RL like you would see for for chess and Go playing or for diplomacy playing. But OpenAI hired the guy who taught a language model to lie to humans via RL and beat them at diplomacy. And so I would expect that they're interested in doing the same with large language models. So we'll see that, I think, coming in over the next couple of years as control of the language models.
Awesome. Are you talking about John Leike? Is that the guy?
He's been there for a while. It was I forget the guy's name. I'd have to, but the diplomacy RL paper.
Okay, got it. Yeah, I look it up and share it in the chat. Awesome. In the meantime, Brian, Katrina, do you want to start sharing the screen and go over your experience building the Cosmos Video API?
Yeah, thanks. Give me 1 second. Hold on, I gotta quit and rejoin. I'll be right back.
Yeah. In the meantime, Katrina, do you want to share a bit about your background, kind of the context behind, because maybe you also talk about the presentation. But yeah, we'd love to get some preamble.
Sure. So Brian will give a good overview of Cosmos, but we are a search and media editing platform. So we started off with an API, but we also have a web app. I see Brian's got the slideshow going, so I'll let him take over and then I'll jump back in later.
Cool, thanks. Hi everybody. So my name is Brian, and I'm going to be presenting today with Katrina. And before we get started, I just wanted to thank the 12 Labs team for inviting us to speak today. We're really excited to be sharing our project with you. So is this sorry, is this a Zoom thing in the where? There we go. Okay. So just a quick overview of what we're going to be discussing today. So what is the Cosmos platform? Why did we decide to build it? How we're using multimodal search in our platform, and a quick look at some of the exciting things that we have planned in the next couple of months. So what is Cosmos? So it is a platform for searching media, searching and editing media, where we're leveraging 12 Labs' powerful multimodal search to search across video content, and then added in our own media editing infrastructure so that folks without media editing experience, or folks who don't spend a lot of time necessarily in video timeline editors, can quickly and easily repurpose existing content into new content, simple things like cropping, resizing, but then, kind of more advanced things that, maybe like a marketing team might want to share. So taking content and adding overlays to it, watermarks, joining content with good looking transitions that look professional. And then we've also built a developer friendly API. That's actually the original concept behind Cosmos, was a standalone API for people to incorporate media editing functionality into their own stack. And to Charles's some of the stuff that Charles was talking about in his last talk, we also envision this being a tool that folks who are experimenting with autonomous agents and large language models could also implement. So thinking ahead to the chatbots today are mostly text-based, but we don't think that's going to be the case for much longer. So in a use case where you want to take a couple of images and stitch them together, maybe overlay some nice intro music or something like that, we think that this would be a really great use case for an autonomous agent to take our API and perform that functionality on behalf of users. And so just a bird's eye view of what our platform looks like in its current state. So as I mentioned, it originated as an API to fulfill those two use cases I mentioned, building media editing into your own applications, or building tools, bots that will edit media on your behalf. And then most recently, we built and launched a web application after some feedback from users who aren't necessarily technical or don't have the technical resources to implement our developer API. They were asking if there were ways for them to use off-the-shelf solution. So we've started building a web application on top of our media infrastructure, and are adding new features by the day. And so at its core, the platform is for users to upload, search, edit, and download their media, and then ultimately distribute it to wherever they have an online presence. So in most cases, it'll be visual platforms like Instagram, TikTok, YouTube, but also increasingly websites. As they become more visual, and you need more compelling content to attract users to your site, or in marketing campaigns, embedding interactive animations or assets into email marketing campaigns is another use case that we've talked to folks about. So the screenshots at the top are some examples of what we would expect some of our users might upload to the platform. So things like online courses, games, so like broadcasts, ads. So basically enhancing the existing video content library that users have so that they can create new content, don't let content go stale, and really empower users who aren't video editors first, or aren't designers first, to take these assets and really create powerful, engaging content. So why do we build Cosmos? In our experience, both professionally and most recently with launching Cosmos as a business, we've learned that working with media tends to be needlessly complex. When you're doing simple things like optimizing your website for SEO, you need your website to load quickly so you don't get dinged on the results. So you need to convert your files to web-friendly formats. You need to resize images for videos for different aspect ratios depending on the platform that you're serving it on or the environment. And a lot of times that involves tools that are really broad in scope, so things like the Adobe Creative Suite or other video editors, where if you're not really familiar with them, it's easy to get stuck down a rabbit hole, or you find yourself sort of tapping a video editor to help you do it, or maybe a designer, or maybe you moonlight as a video editor, so it takes away, I think, from the ultimate task that you want to accomplish, which is take your media, put it in front of people, and iterate on that feedback loop, make it as tight as possible. So the same way that you would share a blog post and collaboratively maybe comment on stuff, work with other team members, we feel like media should be as easy to work with as something like text. And so we like to call this media editing hell. Whenever you're working with some of these requirements that maybe they come from somebody else in the organization, particularly in a business setting, there are a lot of different use cases that will require either an engineer, maybe somebody from marketing, and then somebody from design team to try to stitch these assets together. And so in some of these examples on the left, in broadcasting, for example, if you're watching a live sporting event, you'll notice that they have really crisp, nice highlights that get presented, right before commercial breaks or at the end. Those are typically created by hand, by professional video editors. So there aren't really automated ways to take this existing content and quickly repost it during the live feed, for example, without getting more humans involved. Content creators they spend a lot of time trying to create engaging content, and again, it tends to be very, very time consuming. For marketers as well, if their design is not, or editing is not their core competency, then they end up having to outsource some of this work. And for developers in our use case in particular, like I mentioned, SEO is a place where the format of your media really matters. And if you're trying to move quickly, trying to ship features, your logo or your video files don't look quite right. You've got to upload them, re-edit them, export them, and you just end up spending a lot of time trying to get your content out to the right people. And so this different take on similar problem, where it's there also tends to be this experience. There are a lot of cooks in the kitchen. Like I mentioned, if you are trying to get, if you're working with a team of people in a business setting where you're trying to get your assets, you repurpose some content, you're typically dealing with a couple of different people who have different needs. Marketing is going to have different opinions about the brand consistency, about how the assets look versus what an engineer would like to optimize for versus, coming up against maybe some design principles. So it tends to fall on one person to kind of reconcile all these things because they hold the keys to the tools that make the work easy to do. And so lastly, I'll tell you a little bit about us before Katrina dives into some of the product demos. But My background is in programmatic advertising. So on the engineering side, I spent 4 years at TripleLift, a native programmatic advertising platform, building high volume, low latency web infrastructure and using machine learning to optimize the way that we did our auction dynamics, dealing with millions of creatives per day. And then most recently, I was a Transmit dynamic ad insertion platform where I was doing quite a bit of media editing for publishers who they have their broadcasting assets, but then they want to monetize those across various settings, like their Roku app, their iOS app, etc. And that comes with its own host of problems because of the way the video players expect assets, expect continuity within the assets, and if you don't reconcile the media with the existing playlist, you end up with playlist crashing. And so it ends up being very complex, and you have to automate a lot of it. But a lot of the tools that exist are really only open source, and there's nothing that kind of bundles all of this together. And Katrina has worked at Customer, which is recently acquired by Meta, where she built easy to use platform automation, so specifically around customer support, as well as rule-based access to sensitive data. And so that's something that in the implementation of large language models, particularly in business settings, there's been a lot of discussion around how do I keep my data private? How do I make sure that the right people only have access to the right data? And so in our case, we believe that the trend will extend to people who are working with media, where you necessarily wouldn't want marketing to accidentally incorporate a slide from a confidential internal deck or something like that. And so I'll let Katrina take it from here to discuss some of the product functionality, and I'm excited to answer your questions at the end.
All right, thanks, Brian. Let me share my screen. All right, can everyone see that? Nice. All right, hey everyone, I'm Katrina, and I'll talk about how we use multimodal search at Cosmos. And then I'll run over a few demos and then talk about what we're working on next. So we use multimodal search to provide our users with semantic contextual search of videos that are uploaded to the Cosmos platform. As Brian mentioned, Cosmos started as an API first, where developers could edit media using API requests. And from talking to our early customers, we learned that there was a need for this functionality from the API for teams that do not have engineering resources to implement our API. So with that feedback, we built a web app POC that exposes the functionality of our API. And that's really where we also showcase the usefulness and the power of multimodal video search. So next, I'll walk through a few demos of our API and our web app. So here we have a demo of our API. We're making an API request in Postman. And here we're requesting an image to be turned into video, and the payload is pretty straightforward. It has an edit command and the assets that you want to edit. Our API returns an ID where you can then fetch the download URL and download your final asset. So here we download it, and we can see the image transformed into a 5-second video. And this use case was actually inspired by a 12 Labs user that was converting images to video manually and using, I think, 2 different tools to index the image as video with 12 Labs. So this could come in handy for people that want to index some more images into their 12 Labs indexes. And next we have a demo of our web app. So here is the Cosmos web app. It's still in beta. And on this view here, we're in our production studio. And this shows someone uploading a video into the Cosmos platform. And you can do this in the web app and with our APIs. And once you upload a video to the platform, we index it in the background with 12 labs, so it can become searchable. Eventually, we want to support uploading and indexing images and audio for search as well. But right now, we only support video through the web app. And here's a demo of searching in Cosmos. So we're in the same page in the production studio. We've uploaded a few videos, and here we're going to search for skating. And what's really cool about multimodal search is that we're getting videos with the action of skating returned. We're getting videos returned with objects having to do with skating. Here's a person holding a skateboard. And to demonstrate searching text displayed in video, I uploaded a product demo of Cosmos doing a search for skating. And we see that that video is returned as well. And I think that's super cool because it can be useful for businesses that want to search for online courses or lessons that are very text heavy. And maybe they want to provide an easy search for their users to find the content that they're looking for within those courses. Or you might consider a software business that has a lot of product demos that can also be kind of text heavy, and that this search would be an easy way to surface the exact video they're looking for. And here we have a full circuit of searching for a video, selecting it, and selecting the edit that you want to perform on the video. So in this case, we're converting the video to GIF and submitting that edit. The web app so far only supports converting a video to GIF because that is one of the primary needs of one of our early customers. And this customer wants to convert videos to GIF at scale for their marketing and sales teams to use in email campaigns for sales outreach, marketing outreach, without bogging down their creative team. So they do have a creative team, but they want that creative team to be focused on truly creative projects and free up their business team to get the media they need on their own with our off-the-shelf tool. So later this month, we're going to be exposing some more edits in here that we support in our API, like slowing down video, speeding up video, and converting to other web-friendly formats like WebM. And after you've submitted an edit in the web app, you can go over to our projects library. And in this page, we have all the projects that were submitted. You can get a little preview of it on the left-hand side there, download it, and now you have your GIF. And so what's really cool about downloading these assets on your own, maybe as a salesperson, a marketing person, is that then you can use it to create some more engaging outreach. So, you know, a lot of times you want to show rather than tell. And for businesses that have a sales team that are doing a lot of outreach, it might be more powerful to send an email that shows their product and makes use of video content that the business might have already. So what comes next for Cosmos? The videos we see in social media today are really engaging, and we believe that businesses want to carry that over into their marketing and sales outreach, but they don't necessarily want it to be in social media apps creating this content. They want to use a business tool where they can collaborate with their team and create and download the assets that they need, but that are just as engaging and fun as what we see and we've become so used to in social media. So this is an example of where we're heading. This is a reel of 5 images stitched together with some fun transitions, a watermark logo, that's the Cosmos logo there. And these images were all generated with AI. So we want to give businesses the ability to do this in an enterprise-friendly way. Here we have a video reel where we stitched together 2 different videos. with a transition, and again, a nice logo on the right-hand corner there. So how are we getting here? Here's kind of a broad roadmap of how we see ourselves getting to these kinds of reels that we saw in the last 2 slides. In the next month, we want to focus on business-friendly features like bulk edits. Bulk actions are really important for businesses that just want to, crank out a lot of content. So this would enable people in our app to select a few different videos and convert them to GIF. We also want to expose more edits, as I mentioned before, that you can do on our API, but expose those in our web app as well. After that, we want to continue showing the power of multimodal search and baking that more into our web app. With multimodal search, like with the 12 Labs API, you can search for content and get the start and end time of a specific clip from within a video. And that can be really helpful for companies that have a lot of long form content, longer videos, B-roll, and maybe they just want to extract certain clips. And once we're extracting clips, we want to be able to create edits with those multiple clips. So using multiple files to create a single reel like we saw in the slides before. Once we're creating reels, we want to add some basic editing like watermarks that we saw before, animated overlays and transitions. We believe that these kinds of edits are becoming table stakes because you see them so often in social media that you shouldn't need to rely on a video editor to get some of these basic editing features done. And then heading into the fall, we see ourselves focusing more on image and audio and adding some audio transcription, captions, semantic search for images and audio as well, and generating image and audio based on text prompts so that users can complement their existing media and create more content with it that's in line with their overall brand. And finally, we have some resources for anyone that's curious. As I mentioned, we're in beta, so we love people to test out the web app. There's a link there to sign up, a link to our API docs. We have a blog with some tutorials, and our Discord is in here. If you do use our API or our web app, Discord is the easiest way to reach us for some support or answering any questions. And down here, we have 2 open source tools that we've created and shared on GitHub. The first, Pluto, is a media editing library. It's a library of scripts that rely on FFmpeg and some other tools so that you can edit media on your local machine without making API requests. And finally, here we have a large language model app template that's built on React and Node. So if, like, us, you're curious about playing with LLM apps, this is a good way to get started and just have like a template ready to go. So you're running an LLM app right away, and then you can start adding on to it, like calling other APIs, for example. And that's it. If anyone has any questions, I'm happy to, Brian and I are both happy to answer. Thank you guys for having us.
Awesome. Yeah, thanks for going over some of those very impressive.
James, do you have time for questions, or do you
yeah, we do. I just want to make the transition quick, but due to what is it?
No, thanks for mediating and monitoring everything.
Feel free to ask a question if you want to ask. Yeah.
Cool. Hey, Katrina. Hey, Brian. Thanks for the great presentation, guys. I'm also in like a similar space of like automated media creation. So I kind of wanted to ask, what are some of the interesting videos or other assets that you've converted other assets from or to? Like, was it like, so video to GIF is like an interesting one. Have you used like a combination of other things to make other things? What are some of the challenges there, and what are some of the interesting things you've seen?
Yeah, thanks for the question. I think one of the one of the more interesting like pieces, I think, just because it tends to be like a little bit more complex, but I think it's when you start taking like multiple video assets and start generating like highlight reels, right? Like I think that's a really powerful tool to be able to put in somebody's hand who can say like, I can make professional looking highlight reels, just using this, my existing content library. So, the things that you see on TikTok where it's got like video subtitles that are all timed perfectly and the logos and, sort of like the zoom pan. So, I mean, it's a lot of functionality that any experienced video editor, I think it shouldn't be an issue. But I think if you're like us, where you're kind of thinking code first in ways to, not just like, how do I spend 10 hours creating one of these? Like, how do I write code that's going to make thousands of these? And they all look great. I think that's like one of the really interesting challenges. And, I think from my experience professionally in the sports and kind of advertising world, that's a use case where we think it could be, really compelling for, again, it's like people making content, delivering it at high scale and trying to personalize it, right? So the ability to arm people with those tools, I think it's a really big opportunity, and there are a lot of interesting problems to solve there.
Yeah, absolutely. Like I love too that you mentioned like sports is like sports like it's how quick and how real time can you create these assets? Like I'm guessing processing does take a fair amount of time, or is it not a lot of time? Can it be done within, I don't know, like the time span of an advertisement to be automatically created like from the assets from like real time video?
Sure. So I think it'll depend on I think what formats you're looking at, like the resolution, the time of the media, but it happens you can do it pretty quickly. I think, like FFmpeg, and depending again on like the resolution and stuff, like it tends to work pretty quickly, and depending on like the architecture, in my experience, depending on how real time it is, it's if the SLAs are a couple of seconds and you're talking about maybe like 2 to 4 seconds of content, like that's very doable. But I'd say like it can be pretty real time, depending on the use case.
Awesome. Thanks for sharing.
I have a question as well, if I could interject. My I got forced to do video editing by the pandemic as an educator who could no longer be in rooms with people. And Descript was really helpful for me in like accelerating that process without having to learn Adobe Creator Suite. I'm curious how you see Cosmos fitting into an ecosystem of like other kinds of editors, including ML powered ones like Descript. Is it that you think that like the automation piece and the search piece is like the key thing, and maybe people will move over to Cosmos rather than using the other tools, or do you think it's more of a symbiotic relationship?
I think I think it's really going to depend on like what you're comfortable with, right? And I feel like the video, I'm not familiar with Descript, but just like in general, my experience with video editors, it kind of feels like you're bringing a bazooka to a knife fight when you want to do something really simple, like the timeline kind of interface, things like Canva or Final Cut. You hear stories with people who are just learning, who are like, I made this really flashy logo. It only took me 25 hours. So if your turnaround time is just like, I got, or I should say, if you have other priorities where the actual like design components of it and spending a lot of time in the editor isn't super important to you, and you just kind of want to get the content out, or produce a lot of it, I think there's definitely certainly room for both. But we sort of see it as like, the customer is someone who maybe might not see themselves initially as a video editor, as a content creator, and until they have like this kind of tool in their hands. These are great questions, by the way. Thank you.
Great. Yeah. Any other real-time question that folks want to ask? I'm just looking at the chart right now to see if there's anything that want to be addressed. See. What does boomerang means? Michael?
I think it's something that kids do, and this is what my kids tell me. It's like when the video kind of loops back and forth. You can there's apps that do it that they share around on TikTok. So I think it records like 3 seconds and then goes backwards for 3 seconds. It's just a reverse motion on a piece of action, forward and reverse.
They're really,
That's a good feature idea.
they're very popular for Cheers
Yeah,
videos on
I just heard the
social
term.
media.
I've never made one myself. I've seen them, but it's called boomeranging, I guess. So that and another interesting one would be a meme generator from a set of frames that you've created a GIF from.
Yeah, I think that's the kind of fun content that you see on social media, and businesses are like, how do we do that? And how do we do it at scale? Or how do we do this and like not assign someone to log into Instagram, TikTok, and export it back out and then get it wherever they want their brand to be online.
Yeah.
Yeah, I think that GIF was like, I personally thought it was really interesting. Like Charles, like Descript is definitely, we also looked at Descript, like when we go back to our webinars and try to, there's so much really valuable content there that we all, we also look at, hey, is there portions of this that we can share in shorter form? I think that Descript is like, it's really great for like cutting up short, like the video itself in conversation, and then the GIF, I thought it like in the visual, it's highly visual, and being able to insert that in communication, I think is fundamentally a bit different. The intention is different, and the way you do it would be very different. I thought it was a really interesting use of how multimodal search. Thanks so much for sharing.
Great. Well, if there's not any other question, thanks everyone.
Yeah, actually, I have one last question for Charles.
Go ahead, Matteo.
Like, what about your background? Like, is it real-time code running or like is a dynamic background?
That well, as somebody who was forced to learn how to do video editing by the pandemic, I learned how to use OBS, which is the broadcasting software that Twitch streamers mostly use. And so I'm compositing live the output of my home server's monitoring tool Glances.
That's cool.
So yeah.
Yeah, awesome. Great. Well, thanks everyone for joining. We about 4 minutes over the top hours, but as mentioned, yeah, the recording of this session will be available next week, and be sure to send it, notify everyone when it become available. And yeah, we'll have more speakers coming up in next 2 weeks, talking about different aspects of video multimodal AI. And so yeah, stay tuned for those exciting sessions. Thanks for spending your time just tuning in today, and then hope you have a great rest of your weekend.
Thank you. You too. Thanks
Thanks,
for hosting
guys.
us.
Take care, everyone.
Thanks everyone.